Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the merge to sorted linked list. And for this particular challenge, we are using Java 7 as our language. If you want to use something else other than Java 7, then go ahead. I encourage you to do so. And for this particular challenge, given pointers to the head of two sorted linked lists, merge them into a single sorted linked list. Either a head pointer may be null, meaning that the corresponding list is empty. We have the example of head A refers to linked list of 1, 3, 7, and null, and head B refers to node 1 and then node 2, and then the next one is null, and the new list is 1, 1, 2, 3, 7, and null. If you notice something, that we first return the first one right here, and then the next one we return 2 instead of 3 as arranged is because 2 is lower than 3 with the data that is lower than 3, and the next one is 3 after the 2, and the next one of course it is 7, and the next one will be null. And we have to check to compare between two nodes which one has the lower value or the lower data, and then that node will take the precedence over another. And for the static function right here, we have the singly linked list node called the merge list. This is the expected output in the form of singly linked list node, and that takes two parameters. The parameter 1, which is head 1 in the form of node, and also the head 2 is also in the form of node. And for the function description, complete the merge list function in the editor below. The merge list has the following parameters, like I described earlier, with reference to each head of the list, and the returns is in a form of node, a reference to the head of the merge list. And so without further ado, let's solve this out by checking its cases to see which one is null, one is null, and return the rest. And checking the edge case by checking if the head 1 is null is equals to null, then of course we only return the head 2. The same thing goes to the head 2. If head 2 is equals to null, then we return the head 1 instead. And then if the edge case has been passed, then we need to declare our node change merge from the head 1 and head 2 by declaring our node called the singly linked list node. That's the type of the variable called the new node, and this new node will be used as our answer by creating a new constructor singly linked list node that takes the parameter of 0, and the data of 0 acts as a demo data. And then for the next one, don't forget to declare our pointer. Declare our pointer, new node pointer by creating another singly linked list node called the current node that takes the new node as our pointer, and then to check. But before that, we need to return our new node. Since it is the new node will be creating as the node with the data of 0, then of course we have to return the data of 0. This one is used just as a purpose of creating the node chain, so 0 will be omitted, and we should return the actual value from either node 1 or node 2, or the head 1 or the head 2. So that way we can shift this by using the new node dot next, and then we are returning after this constructor right here. So and then the 0 data will be ignored from our new node, and then we only return the new node dot next using the next property, and the 0 will be omitted from our answer. So for the next one, we need to declare check check if both nodes are not empty or null by using a while loop to iterate over the head 1 and head 2 by using the while the head 1 is not equals to null and the head 2 is also not equals to null. As long as both nodes are not null, then of course we can check which one has the lowest value or data, as we describe right here. From the first example, we have 1 1 1 3 and 7, and the next one is 1 and 2. Then of course for the merge node chain, we have 1 1 2 3 and 7, and then 2 will be the first one to be returned as the node chain, and the 3 will take the next property after the node 2, and also the 7 will take the next property after the node 3. And we can add check if the head 1 is below than the head 2, is in the head 1 with the property of data, and also head 2 with the property of data. And then we can assign the head 1, assign the current. Remember, we are using the current as our iterator over the new node chain, using the current dot next, attacks the head 1 as the node, and then we move the head 1 to the head 1 dot next. If you notice something, I made a mistake right here. It should be a pointer from the head 1 and head 2 instead of using the head 1 and head 2 parameter directly, just like we declare the current pointer of the new node as the iterator. So let's solve this out by creating a pointer. Create both pointers for params. We cleared using the singly linked list node called the current 1 or C1 that takes the head 1 as the variable, and then singly linked list node under singly linked nodes in the C2 as the head 2. Instead of using head 1 and head 2, then we need to declare using the Control D to select multiple variable name, and we change the head 1 to C1. And for the next one, for the head 2, we can change the head 2 using the Control D again to select multiple variable using the C2 instead of head 2. And that takes with the C1.data property. If it is lower or equals to the C2.data, we compare them to see which one has the lowest value. Then of course we are returning that one that takes the precedence over the other, and we can add a check else using the else to see if it's the other way around, and then we can simply rotate and copy this one. For the current dot next, we use the C2 as our assignment of the next property, and then we move the C1 to the next pointer and C2 to the next pointer. And don't forget to move our new node pointer, because we already check either one is fulfill the statement from the if and else check. Then we simply return only one using the current equals current dot next, and we move the pointer to the next property or the next iteration of the current node dot next. And if either C1 or C2 is already null from our while loop check, since while loop only fulfills if either or not either but both of them are not null from the pointer after the dot next, and also using the C2 equals C2 dot next, and we can add the check which one is already null, then return the rest of the other. Using the if the C1 is already null, then of course we assign the current dot next in the current dot next using the C2, and we assign C2 to the rest because the C1 is already null. And it also applies to the other way around using the else. You guess it, we can check if the C2 is already null, then of course we are using the current dot next using the C1. And let's run the code to see if it works. I hope so. Okay, so that's about it. Let's submit this out. Okay, thank you for watching the video. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. I hope you have a great day, and I will see you in the next video. Goodbye.